All right, example 15. Naisha. What is the charge on the blue charge, and how does the magnitude of the blue charge compare to that of the red charge? So, what do you think the charge on the blue charge is?
Positive.
Positive. Why positive?
Outward. Arrows are going outward.
Good. Arrows are going away. How does the charge on the blue one compare to the charge on the red one? The blue one has what?
Smaller.
Has more charge because it has more lines. Okay. More charges, more field lines. Any questions? Any questions?
So how do we like? What's the measure or what is the number? Like, what do we say it has like 3 more charges?
No. You see, we can't really say much about what the charges are compared to each other. Okay. Because this one has 5 lines, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could say this one is like 5 protons, and this one would be how many protons? 9 protons. We could say something like that, using the ratio of the field lines. But if this one is like 1 proton, then this one's like 1.8 something protons. Okay? Alright? We just know that the blue one has a larger positive charge. That make sense? Yeah. Okay. Any other questions? We got that? Make sense? Okay. Example 6. Rank the locations based on the force felt by the positive test charge. Explain your reasoning. So, which location, A, B, C, or D, will feel the greater force? Which one will feel the greatest force? If I put a test charge at either of these locations, which location will the test charge feel the greatest force?
I say B.
You say B. Why B?
Because there's more lines.
Good. There's more lines at B, right? So the field is stronger. Since the field is stronger, a charge placed at B will feel a larger force. Okay? Which one feels the second largest force?
D.
D?
Yes.
Okay. I would say D and A are probably pretty close. Okay? If this were a test question, it would be tough for me to distinguish whether D is the next or A is the next. So I'd almost say those two are equal. Okay, so if I were to draw boxes around these two, they probably would both enclose two lines.
There's that line above. You know what I'm talking about?
Yeah, but it's not the proximity to the line. Okay, because remember, the electric field is everywhere. Right? I don't draw every possible electric field line here, because then I would just have a purple disk surrounding this charge. Okay? Just because there's no line here, Sergio, just because there's no line here doesn't mean there's no field there. Okay, does that make sense? Alright? So, the charges are about equally spaced right here as they are right here. So that's why, or sorry, not the charges. The lines are about equally spaced at A and as they are at B. Okay, does that make sense? Yeah. Okay. And which one's the weakest? C. C is the weakest. Does that make sense? Yeah, because it's the farthest away from a charge, and this charge is the weakest. Right? The red charge is weaker than the blue charge. D is further from the blue charge, but it still feels approximately equal force to A because of the field line density. Okay, Kevin, does that make sense?
I said that.
Okay. All right, just making sure. Okay, so this brings up the idea of electric fields and force. So, guys, we said electric fields are what tell or protons and electrons feel to know they should repel or attract, right? So let's say I have an electric field. Let's say this electric field is to the right. Say it's 200 newtons per coulomb. Okay, that's the electric field straight. If I say newtons per coulomb, where'd that come from? I'll show you in a second. All right. Let's say I put a proton in this electric field. And I put an electron in this electric field. Which way does the proton feel the force? These black lines are the field lines. Which way does the proton feel the force?
Upper right.
Some of you probably went to Star Wars. Okay. Which way does the proton feel the force?
Within.
Remember, field lines point in the direction of the force felt by a... By what, kid? A proton, by a positive test charge. So the field lines point to the right. Which way does the proton feel the force?
Yeah.
To the right. So the proton will feel a force this way. Right? To the right. In the same direction as the field. Which way does the electron feel a force? Which way does the electron feel the force? The opposite direction. So the electron will feel a force in this direction. That is the way the electron will feel the force. Does that make sense? Guys, any questions about that? You understand how it works? Okay. Now, I told you this was a field strength of newtons per coulomb, right? Right? So what that means is electric field equals what? What two quantities? Newtons is a force, coulombs is a unit for charge. Good. So the electric field equals the force felt divided by the test charge. Okay? E in this equation stands for the electric field created by some large charge. Okay, I'm putting parentheses big Q. Okay? There's some big Q out in the hallway over there that's making this electric field. Okay? It's so far away from where we are, I can't draw it on the board. Okay, it's out there somewhere, out in the hallway. Alright, does that make sense? So there's some large charge making this electric field way over there. Okay? What's Q? Test charge. Small charge, right? Q is a test charge. Okay? Small charge. Okay? Big Q is like hundreds of thousands of protons or electrons. Little q is like one proton or one electron. So it's like big Q is the sun and little q is Earth. We're getting back to that whole gravitation analogy. Okay? Or it could be the moon too. Okay? Moon and the Earth are similar in size when compared to the sun. Okay. What's F? Force. Okay? F is force. Now this force is the force felt by the charge. Which charge? Both! Right? Why is this F both? Why is it the force felt by both?
Because it has
Newton's third law. If this test charge feels a force that way, there's some big charge out in the hallway that feels a force in the opposite direction. Because of Newton's third law. Okay? So F is the force felt by the charge. Okay? Does that make sense? Guys, does that make sense? Any questions? Okay, here, little q is positive, right? So that means F and E are, remember the black lines are the electric fields, the blue lines are the forces, right? If our q is positive, E and F are
neutral. I give up.
in the same direction. They both point to the right. Okay? If Q is negative, E and F point in. No. Opposite directions. Right? Positive Q. Positive on the bottom. These two are both positive, right? Right?
Yep.
Negative on bottom. That means if F is negative, E is positive. If F is positive, E is negative. Okay? And that kind of confirms our ideas that positive charges go in the same direction as the field lines, and negative charges go in opposite. Okay, any questions? Any questions? None? Okay. What's the charge on a proton or an electron?
Like 1.6.
Times. Good. So for this proton, Q equals 1.6 times 10 to the negative 19. Oh, not new ones. Coulombs. Right?
The same for
For this electron, Q equals 1.6 times 10 to the negative 19, except it is negative. Okay. So can we use this equation to figure out the force? Yeah. Okay. For the top one, for the proton, we know 200 equals F over 1.6 times 10 to the negative 19. Right? Simple problem. How do I get the 1.6 off the bottom? Multiply. So 200 times 1.6 times 10 to the negative 19, that's what the force equals. Oh. Kevin and I do have fun with this. That's why I like teaching. Okay. So 200 times 1.6 times 10 to the negative 19. What do we get? Michael?
3.2 times 10 to the negative 17.
3.2 times 10 to the negative 17 units. Newtons, good. Because electric field is newtons per coulomb. Probably should write that down. Electric field is newtons per coulomb. Okay? Charge is in coulombs. Newtons per coulomb times coulomb makes newtons. Okay? Now, since this is positive, right, and my electric field is positive, that means we're in the same direction. Right? So F and E are in the same direction. Okay? Okay, let's talk about the next one. Guys, for the electron, how does this change?
It's the opposite.
It's the opposite. It is the opposite. Well, let's prove it. Okay. So, for the electron, our electric field is still 200. F divided by negative 1.6 times 10 to the negative 18. Okay. So how do I solve this again? Kevin, how do I solve this again? Good, multiplying the bottom by 200, right? So force again equals 200 times negative 1.6 times 10 to the negative 19, right? So when you multiply that out, what do you get?
The same thing, just negative.
The same thing, just negative. Now, since our force is negative and the electric field is positive, that means they point in opposite directions. Okay? So these calculations agree with our rule that field lines point in the direction of the force felt by a positive charge. Okay? So F and E are opposite direction. Any questions about that? Any questions? No one? Yes.
So because of the F being negative and then the for electric field being positive, they move in opposite direction.
Right. So for the electron,
Yes.
yeah, since the F is negative and the field is positive, that means they're pointing opposite directions.
That's what we're looking for always in a situation like that.
No, in this situation, what I've given you is I've given you the electric field strength,
Yes.
which what the 200 newtons per coulomb is. That's the electric field strength. And we were able to figure out the force exerted on the charge. Okay, does that make sense?
Yes.
Okay, so the equation that we need to remember, Michael, is this one. Okay? All right, any other questions? Now, is anyone at all concerned with how big Q is? Big Q is? Is anyone at all concerned with how big Q is?
No, it's pretty small.
Pretty small, you sure?
Yeah, and it has a little gap in between the lines there, so.
Oh, maybe it's like a U.
Yeah, it's a U with a line.
Well, how could I find out what big Q is?
By closing the circle.
Anybody know?
Like E times up.
Well,
If you want to find Q, use the alphabet.
the equation, if we alphabet serial, we'll find it, no problem, right? The equation E equals F over Q. Right? That's what we start with, isn't it? Yeah? That's the equation we start with. Electric field equals force divided by test charge. Right? Okay. What two charges were involved in this force? We had the big Q and the small q, right? Over radius squared
I remember KQ, I don't remember K big Q, little q.
divided by q. Okay. Big Q and little q, Kevin, is just like big M and little m. Remember we were doing gravity at big M and little m? Big M was the big mass, little m was the little mass, right? But there's still two m's, right? Same thing here. Q is the big charge, and little q is the small charge. Okay? So, can anybody simplify this equation so that I can find out what big Q is? What should I do?
Can't you put the
Right down.
Ah, close.
Multiply the R squared.
Nope. We have a Q on top and a Q on bottom, right? Cancel them. So that gives me an equation that we can use to figure out.
Oh, so that's two.
Yep. That gives me an equation that we can use to figure out big Q in this situation. The charge originating the field. The charge creating the field. Okay. So big Q in this case, big Q is the charge creating the field, or the origin charge. Okay. The charge that creates the field. It originates the field. Okay. Now, if big Q is positive, the field points away from it, right? If big Q is negative, then E points in, right? So if big Q is positive, then E is positive, points away. Okay? Do this if you want to. Okay? That make sense? If big Q is negative, how's the electric field point? In. So if big Q is negative, then E is negative, and it points in. Does that make sense? Okay, Sergio, take a seat. I got 6 minutes left, bud. You're gonna need those calculators. You're gonna need them. Okay, don't worry. You have time to put them away. It'll be a quick problem. So, let's say we had that big Q, right? And we had that 200 Newton per Coulomb field strength somewhere over here by our proton and electron. Notice I drew them really small now. My proton and electron are tiny now, aren't they?
Why?
Because I've taken the picture we started with and we zoomed way out, so now we can see big Q. Let's say big Q, I said is out in the hallway, so that means we'll say it's like 3 meters away. Okay, so I said big Q is somewhere out in the hallway. All right, through the wall, outside. So that 3 meters is what?
The radius.
The radius. So R equals 3 meters. We know big Q is what we're trying to find. K is 9 times 10 to the 9th. E is 200 newtons per coulomb, right? Right? Can we find big Q?
Wait, so is E the constant?
No, K is constant.
Wait, so I forget E.
Because from what we started with, 200 newtons per coulomb force.
Oh, but it's not. I wasn't gonna do that.
No, it's 200 newtons per coulomb at that spot. If I move this way, what happens to the electric field? What do you think?
Like the radius.
If the radius gets smaller, what happens to E?
It gets bigger.
It gets bigger. So if I'm closer to Q, that E field is bigger, Sergio. Okay, does that make sense?
Yeah.
Okay. So now we can figure out Q. So we start with this equation, E equals KQ over R squared, where big Q is my charge originator, or my field originator. So 200 equals 9 times 10 to the 9th times big Q over 3 squared. Right? What's 3 squared? 9. And that's a tough question. So 200 equals 9 times 10 to the 9th Q over 9. Right? There's 2 ways. We can multiply by 9, then divide by 99. Right? Or we can simplify this side and divide once. Okay? What do you guys want to do?
So the simplify.
Want to simplify then divide once? Okay. Well, there's a 9 in both, right? So these cancel. What am I left with on top? A 1. So you have 200 equals 1 times 10 to the 9th Q. Divide by 1 times 10 to the 9th, and this turns into a problem that I do not need my calculator for. Because when I divide by negative 9, or I divide by 9, that makes the exponent,
5.
makes it negative, right? So we end up with 200 times 10 to the negative 9 equals Q. And you could just do this in your calculator if you want to. I can move my decimal place 2 spots and get 2 times 10 to the negative 7 coulombs equals Q.
Yep, you're right.
Okay. So you can do it without your calculator. Or if you did it with your calculator, that's fine too. Okay? Guys, if you multiply 200 by 9 and then divide by 9, E9, you should get the same thing I got. 2 times 10 to the negative 7. Alright? Any questions?
Is it a positive charge?
Is it a positive charge? Yes. Okay? I know that because the field lines point to the right, away from my Q. Okay? If this was a negative charge, then I would have got a negative answer when I figured it out. Okay?
Wait, so
Okay, we'll get more practice with this tomorrow. Alright?